friends. Okay, so today is our last lesson in exponents and logs. And this one's in logarithmic differentiation. Now, this is fun. I know most of you don't like it when I say this is fun because I know you feel my definition of fun and your definition of fun are not the same thing. But this is also known to you, okay? There's actually, like, as I go through this note, there's nothing that I'm about to do that you haven't already done. Have you ever thought to do it this way, or have you ever thought to put this piece and this piece together in the same question? Probably not, but that's what we're going to do today, okay? So hopefully the math behind it, although the math is a little bit more involved than what we have been doing the last couple of days, although the math behind it is familiar, it will be new to put it in like this. So, okay, I'll be quiet and we'll just get going. See what you think of it by the end of it, I guess. Okay, so here's the premise of what we're doing. We're going to kind of combine our knowledge of 30-1 log laws with our knowledge of implicit differentiation, okay? And then we're going to use that to differentiate more complex functions that have a bunch of exponents, okay? Essentially, we will turn an equation from a series of products into a series of terms because a series of terms is much easier to differentiate. Let me put it this way. If I had x squared plus 5x to the 4, you can differentiate that pretty easy, right? Because you can go just each term, figure out the derivative. But if I had something like, I don't know, x plus 1 to the 3 times x to the 5 times x minus 2 to the 4, and I wanted to differentiate that. Here you can see there's a problem, okay? I could multiply all of that out so that I could then differentiate each term. That is a possibility. It's a really long possibility though. And the product rule only works if I'm multiplying two things together. This is multiplying three things together, okay? So, I mean, I could multiply two of these things together and then use the product rule. I could try that too. Again, that's really long. And what I want to show you today is, I think this way is an easier way, even though when you look at it, you may not at first say it's easier. It's an easier way to get to the answer that you need, okay? So here's what we're gonna do. We'll take the natural log of both sides. Then we'll use log rules to break the equation into separate terms. So a reminder, when we are taking the log of something, several things that we're multiplying, we can expand that out to be separate log additions. When we're taking the log of things that we're dividing, we can expand that out to be several log subtractions, okay? And the power log law, if you have an exponent on the thing you're taking the log of, that can come to the front. All of those are going to be super, super useful to us moving forward, okay? So we're going to use those log rules and laws to break the equation into terms, and then we're going to do implicit differentiation. Okay, at the end, we still don't want y there if possible. So what we're going to do, which we did this when we were differentiating, when we were trying to figure out the differentiation of logs a couple lessons ago, we're going to replace the y with the original equation so that we don't have any y in our answer, because you can do that when there's only one y there. With implicit differentiation, often there is multiple y's in multiple spots, and so that makes it a little trickier. But in the way these guys are set up, it'll be easy to get rid of the y, okay? Okay. So if I want the derivative of this, see, now the problem is I don't actually have a rule for this right now because I've got a variable in both the base and the exponent. If I just had that variable in the base, we know how to take the derivative of that. If I just had that variable in the exponent, we know how to take the derivative of that. But it gets a little trickier when it's in both places. So what I'm going to do is I'm going to take the natural log of both sides, okay? Taking the natural log is an algebraic process. So as long as I do it to both sides, I haven't changed the equality statement. okay? But now what that allows me to do is this exponent can now come to the front, and I can treat this as ln y equals, oh, sorry, I thought that appeared for you. ln y equals x ln x, okay? Well, now I can differentiate a little easier. Here, I've got 1 over y times the derivative of y. And here, I've got the product rule. So the derivative of x is 1 times g, which is ln x, plus f times the derivative of g, which is 1 over x. Okay? So now this is going to give me ln x, and this is going to give me plus 1, because that's x over x. I want dy over dx all by itself. So the other thing I want to do here is I'm going to multiply both sides by y. That will get rid of my division of y over here. Okay. And so that's what I've done here. This cleaned up to be ln x plus 1. And then I multiply both sides by y. Okay. But y isn't y. Well, I mean, it is, but it also equals x to the x. So now I'm going to replace my y back with x to the x, and I have a differentiated function. Okay, don't miss what just happened. Sometimes we can get caught in, you know, just the math of life. The math of life, that's very philosophical. That represents the slope of all tangent lines that can be formed along the original function. That is what the definition of a derivative is, okay? All right. Now, that was the absolute easiest question that I have for you today. Let's do one more fun. Okay, so I can hear the groanings in the cyber land. Okay, so again, this is kind of like the example I showed you up here, where I have multiple stuff that's going on that's being multiplied. So I am going to take the natural log of both sides. When I do that, this guy here, I want to switch to blue so it will contrast with the pink. So this guy here now becomes ln of ex squared plus ln of x cubed plus ln of x squared plus 4 all to the 3. And then I can start differentiating that. Okay, so the next step I would do is just bring your exponent in the front. So that'll be ln y equals 2 x squared, sorry, ln e plus 3 ln x plus 3 ln x squared plus 4. So I'm using that power log law to move all the exponents into the front. Now I can take the derivative, but taking the derivative of this is actually like 1, 2, 3, 4 fairly simple questions at this stage, right? The derivative of ln y would be 1 over y times the derivative of y. Ln e is just 1, right? So we're looking at the derivative of x squared there, which is 2x. This would be 3 over x. This would be 3 over x squared plus 4, but then I have to take the derivative of the inside function, which would be 2x. Okay, so that's everything I think I just said. See, that's not bad. The math involved isn't as bad as maybe it looks like when you're just staring at a bunch of lines. It's all good. Don't stress. You got this. Okay, so now I need to clean some things up. Obviously, this is going to be 6x up top here. And I want a common denominator. So my common denominator is going to actually have to be x times x squared plus 4. I'm also going to multiply both sides by y. Okay, so this guy is going to have to get multiplied by x and x squared plus 4 in order to get a common denominator. This guy is going to have to get multiplied by x squared plus 4. And this guy has to get multiplied by an additional x. Okay? I really hope you're pausing me in a lesson like this and you're trying to do this before I show you the next line, right? Everything looks great when I do it. Well, maybe not everything looks great when I do it because maybe I screwed up, but most of the time, everything looks great when I do it. Okay, so that's going to give you, let me get the ink out of there for you. So all I did there, I got too excited and I've told you a couple of steps. So all I did there was I multiplied both sides by y and I brought this 2x up and multiplied it by 3. Okay, now I'm getting that common denominator. Okay, so take a look. Don't freak out. Let me show you what I did. I took my 2x and I multiplied by x times x squared plus 4, just like I said I would. I took my 3 and I multiplied it by x plus 4, x squared plus 4, sorry. And I took my 6x and multiplied it by x. That was me just getting a common denominator, so the whole thing could be over x times x squared plus 4. The other thing I did at this stage was I took my y and I replaced my y with what y actually is. Y is e to the x squared times x cubed times x squared plus 4 cubed. So I've stuck that in my equation. So now my equation doesn't have any y's. Okay. Now I can still work on cleaning this up a wee bit. X, so this is all being multiplied, right? So the x squared plus 4 cubed can turn into an x squared plus 4 squared. My x cubed there could turn into an x squared. Okay, and then this can all get multiplied and like terms collected. So this will be 3x squared plus 12. This will be 2x squared times x squared. So that'll be 2x to the 4 plus 8x squared. And then I can put all that together. So I'm going to give you a sec to do that, or you're going to shut me up with the pause button and you're going to do that yourself. And here's where we are so far. So I did that, dropped the x cubed to x squared and dropped this guy from a 3 to a 2. So I got rid of the denominator and I've multiplied that. I still have to multiply these guys in and combine like terms there before I'm done. Okay. So here's my last line with all of those like terms collected together. 2x to the 4 plus 17x squared plus 12. Okay. Some of you may look at this as a friendly trinomial. It looks decently friendly. Two numbers that multiply together to give me 24 and 17. 1, 24, 2, 12, 3, 8, 4, 6. They don't exist. Okay. So I wouldn't need to take that any further. Okay. That was question number 2. Looking at the difference between question 1 and question 2, aren't you now like super excited for question 3? I know you are. Okay. I gotta get my mouse working. Here we go. Oh, yay, it involves trig. Okay, so some of you may say, hey, well, this is just the product rule. Yeah, sort of. It is just the product rule, but then there's also an exponent on one of the products. And so that also involves the chain rule, right? So we're going to try this with logarithmic differentiation and see if you like that better. So I'm going to take the natural log of both sides. That allows me to split this up into two terms that are going to be added together. So that's ln y equals ln x squared plus ln sine x. Now I'm going to take my exponents. I'm going to use that log power law, move them to the front. So that would be ln y equals 2 ln x plus, and then this moved to the front. So that was cos x times ln sine x. Now I'm ready to differentiate. Okay, so the derivative of ln y is 1 over y times derivative of y. This would be 2 over x. This is now the product rule, but it's a shorter, quicker product rule. The derivative of cosine is negative sine times ln sine x plus cosine times the derivative of this. Well, the derivative of this would be 1 over sine x times the derivative of sine x, which would be cos x. Okay. Okay, so we want to clean this up. I want to multiply both sides by y to get rid of my 1 over y there. What else do I want to do? Cos times cos right here. those can be multiplied together to give me cos squared. So that's going to give me cos squared over sine x, cos squared x over sine x. Okay. And then I am going to start approaching a common denominator here. So all I've done so far is I multiplied both sides by y, and I just multiplied those cos squares together. Okay. So if I wanted this to have a common denominator, my common denominator would be over sine x right now. So I would need to multiply this guy by sine x and this guy by sine x. So that's going to be negative sine squared x over here. And this would be 2 sine x here. I'd also need to multiply by x in order to get a common denominator. My common denominator would be x sine x. Okay. So that means this guy will need an x and this guy would also need an x. The other thing I want to do is I want to take that y and replace it with what the original function was. I don't know what that's going to look like in the exported video, but the way I drew that, it almost looks like I'm pointing a gun to my head. Some of you may feel like that when I do math. I don't know, but please don't shoot me. Okay. So I've replaced my y, and then I've got that common denominator that I was talking about. Okay, so I've got 2 sine x, and then remember I multiplied this guy by x and by sine x, so that gives me negative x sine squared x ln sine x. And then the last guy I had to multiply by the x, so that was x cos squared x. Okay, now one of my x's will divide out, x squared divided by x. Can't really touch the sign because of the exponent that's there. Okay. But I did simplify out my x. Isn't this fun? This is what you do when you're in a state of stress. Okay. If you're having a bad day, sit and do some of these questions. It'll make you feel better. Okay, last question. Y squared equals the root of x plus 1 over x minus 1. I know it's never good when a teacher laughs as they're reading the question, right? I get it. No, it's not as bad as you think. Okay, so what am I going to do? Well, the root of x plus 1 over x minus 1 is really just x plus 1 to the half and x minus 1 to the half, right? So I might as well write it like that first. Remember, if I can make these with a bunch of exponents, I can actually handle that well with taking the natural log of both sides. So if I go ahead and take the natural log of both sides, I now can take my exponents. Oh, sorry, I took the natural log of both sides and I applied the log law that I haven't used yet. Notice that this was division, right? So if I have ln of something divided by something, I can expand that out to be subtraction. So I have ln of x plus 1 to the 1/2 minus ln of x minus 1 to the half. Okay, so now what I want to do is I want to apply the log law. So the 2 can come, the power log law, so the 2 can come to the front. I've got 1/2 to the front and 1/2 to the front, and that's going to give me this guy. Okay, and now I'm ready to take the derivative. So I'm just going to look at each term as I go. I've got 2 ln y. Well, the derivative of that would be 2 over y times the derivative of y. This guy would be 1 over 2 times x plus 1 times the derivative of the inside function, but for that guy, it's just 1. And then this guy would be minus 1 over 2x minus 1. Again, times the derivative of the inside function, but in that case, it's just 1. Okay, so here's where we are so far. The next thing I want to do, I want to multiply both sides by y over 2. That's going to get rid of my 2 over y. That's right here. Okay, and I want to work on getting this to be a common denominator. So I already have a 2 on the bottom for both. That's okay, but I need an x plus 1 and an x minus 1. So this is going to turn into be x minus 1 on the top minus x plus 1. Keep that x plus 1 in brackets over here, just as a little reminder, because you've got that subtraction sign, and that subtraction sign has to go to both terms, okay? Okay, so that's what I've done here, and then I haven't multiplied by y over 2 yet, but I'll do that in a sec. I've got x minus x, so that's gone, and I've got -1 minus 1. So I'm going to have -2 on the top, but then the -2 over 2 could reduce to -1 over x plus 1 times x minus 1, and I'm going to multiply that by y over 2. Okay. Then I got to put my y back. My y was, okay, so we have to have a little talk about this. Think about what I just said. I got to put my, oh, you know what? My big old head might be hiding what I just did there. I'm going to hide myself for a second so that you can see that. Sorry, when I'm doing the video, I move my head all around. So I don't remember that my head's always in the top corner. Okay, so you got that. I'm going to put myself back. Okay, I got to replace y. But here's the thing. I don't have y right now. I have y squared. And so I'm going to have to square root that. Now, the square root of a square root is a fourth root, right? So if y squared is the root of x plus 1 over x minus 1, y is the fourth root of x plus 1 over x minus 1, also known as x plus 1 to the 1/4 over x minus 1 to the 1/4, okay? Okay, so now when I go to clean this up, think about this for a sec. On top here, I have x plus 1 to the 1/4, okay? When I divide powers of the same base, I can subtract the exponent. So 1/4 minus 1, because this guy has an exponent of 1 right here. That'll be 3/4, -3/4. So I'll end up with x plus 1 to the 3/4 on the bottom. Then this guy is x plus 1 to the 1/4, but it's already on the bottom. So I've got 1/4 plus 1 here, so that'll be 5/4. Okay, so my simplified version will be -1 over 2 x plus 1 to the 3/4 times x minus 1 to the 5/4. Okay, awesome. So much fun. Okay, I'll be quiet now and I'll let you guys work. Here's what you're doing, and take your time with it. Make sure you're communicating everything that I've showed you, and connect with me if you do have any questions, okay? You got this, guys. You got this. Have a great day. We'll talk to you soon.